Here we go with some more elimination systems problems. We're at the top of 67, and here are the two exceptions. There's always exceptions, and we've had a bunch in previous lessons, and here come two other possibilities that can happen. On page 66 and on page 65, we came up with nice XY answers that worked, and everything was great. These are the exceptions that might happen when you try to solve using elimination. So again, we say, okay, I don't have anything that's going to automatically cancel out when I add them together, but I do see that if I multiply this second equation by -2, it will cancel the x's out nicely. So I'm going to go ahead and do that. That would be minus 2x minus 6y equals minus 18. So I'm going to add the two together. When I add these together, and that's a 0, and that's a 0. Everything cancels, top and bottom, and I end up with a statement that says 0 equals 0. So this might look kind of familiar to you. When you see a true statement and all of your variables are gone, and you have a true statement, this means, and here's the therefore symbol, therefore, there are infinite solutions. Remember, it's not all real numbers because it's only ordered pairs, x's and y's, that will make this true. But there's an infinite amount of them. So you don't say all real numbers. You say infinite solutions. So there are lots and lots of XY pairs that when you plug into both of these equations, it will make a true statement. There's not just one ordered pair that is the solution. The other exception type problem is this one. Again, we don't have anything that's going to cancel out without us doing a multiplication problem, but I'm going to choose to multiply this second equation by -1. And I'm going to get positive 2x minus 5y equals minus 12. So I'm going to go about my business adding together, and I get, again, these are going to cancel. These are going to cancel. So I've got a 0 on this side of the equal sign, but over here I've got minus 5. Well, of course, we know 0 does not equal minus 5. So that means there are no solutions. Absolutely no XY ordered pairs that you can plug in and make this a true statement that work for both of these two equations. So E, we had an infinite amount of solutions, and F, we have absolutely no solutions. I'm going to go ahead and work this first word problem using elimination. This is much like a problem that we have worked a couple different other ways, but we're going to actually, because they tell us they want us to use elimination, we're going to set it up and use elimination. So again, I've already pre-made my chart. We've got a student and adult ticket thing going on here. We've sold 101 tickets. They give us a student price and an adult price and tell us the total ticket sales. And they are asking us how many student tickets were sold. So I've set up my students and adults. How much does each ticket cost? How many tickets were sold? I'm using two variables. I'm choosing to use X for the student number of student tickets and Y for the adult number of tickets. You can use any variables you want. They total up to 101. The amount involved, the dollar student tickets plus the $2.50 adult tickets, add up to $164. So here's where I'm actually going to start with writing in the video. I've got these two equations. Remember, we can use graphing and we can also use substitution. But to use elimination, I've got to get one of these variables to cancel each other out when I add the two equations together. So I'm going to choose to multiply this top equation by -1. And if I rewrite it down here, I get negative x minus y equals negative 101. Now, if I go to add these two together, my x's cancel. I've got a positive 2.5y, and I take one whole y away, and I end up with 1.5y equaling, and 164 minus 101 is 63. So now I can hop on the calculator, which I'm doing as we speak, divide both sides, and I get y is equal to, what I get, 42. So y is, uh-oh, made it bigger or something. Where did I go? I have to go to the next page. Bear with me here. Here I am. Oh dear, it's one of these crazy things where it's got me all off here. So why I let be the adult tickets. There are 42 adult tickets, but that's not what they're asking me for. They're asking me for the number of student tickets. So I have to take 101 and subtract 42. And the answer to the question that they're asking here is 59. And I wrote 55. 59 student tickets were sold. So I'm going to stop this video because obviously this thing is kind of wonky right now. I'll come back and we'll talk about example 3B in the next video. You might see if you can work it on your own. Bye.